Okay, number 21 from section 10.2. Now again, u and v are these two vectors. And that's in their standard representation, so we've got the horizontal and vertical components. So that makes it real easy to work with. So number 21, they want 2 times u minus 3 times v. First of all, they want the vector in component form. So let's just do this step by step so we don't get confused. So 2 times u will equal 2 times 3 is 6. Yep. Minus 4. And then 3 times v. So that's going to be negative 6 and 15. Just 3 times negative 2, 3 times 5. So scalar multiplication is pretty easy. And I want to take so now we're going to take 2u minus 3v, so we'll just subtract 3v from this. So this would be 2u, the horizontal components would be 6 minus negative 6, and then minus 4, or negative 4 minus 15. And that's going to equal 12 minus 19. So that's what you got there. So that's the vector. It's pretty easy. And then we want the magnitude, so we want the magnitude of this vector. So this is like our A and this is like our B, so it's just going to be the square root of 12 squared minus, plus negative 19 squared. Okay, and that's just going to be the square root. 12 squared is 144. Plus a negative 19, takes a negative 19 squared. Okay, I'll get my calculator out there. And negative 19 squared. Enter. And I get 361. And then I'll just add that. And I get 505. And that's not a perfect square, so we can just leave it like that. So that's going to be equal to the square root of 505. There's your magnitude of that vector. Okay, so not too bad. And then number 23. 3/5 of u plus 4/5 of v. Oh, man. Okay. Okay, so A, we want to find just the vector, so we'll take 3/5 of u would equal, and u was this going to be, so just be times 3, and then 3/5 times negative 2. And that's going to equal what? 9/5, and then minus 6/5. Okay, and then we also have 4/5 of v. And what was v? V was negative 2. And then 4/5. And the y component was 5. Well, that's a little nicer. Negative 8/5, comma 4. Now we have, we want to add these, so that's not too bad. So So I want to add these two vectors here. Let me mark this so I know what I'm doing here. So I'm going to add those two, so that won't be too bad to add. So when you add these, I guess I could do it over here. So I just add the components. So what's 9/5 minus 8/5 is 1/5. And then negative 6/5 plus 4. Oh man, what's 4? 4 is 20 over 5, right? Okay, so negative 6/5 plus 20/5 would be positive 14/5. Just add those, okay? So negative 6/5 plus 20/5 is positive 14/5. So that's that. Now we want to find the magnitude of this vector, so we've already got our a and b, so that's not too bad. We just have to put this in radical form, which might be a little bit of a pain. So we want the magnitude of this, 3/5 of u plus 4/5 of v. That's just going to be the square root of 1/5 squared plus 14 over 5 squared. Okay. So that's going to be the square root of 1 over 25 plus 14 squared. I got my calculator. 14 squared, just to play it safe, is 196. Yep. I got a bunch of 25s there, so I can rewrite this. So I'll do a little arithmetic here. All right, this is a common denominator. 1 plus 196 all over 25. That's the square root of 197 all over 25, which is the square root of 197, all over the square root of 25. And that's just going to be the square root of 197 all over 5. And that's your magnitude. Sorry about my sloppy writing over here. 197 over the square root of 25. So we broke it up, and we got 197 over 5, and I think that's kind of the answer that the book had. That's the form they had. Okay. So just some fractions and a little bit of arithmetic, but nothing too terribly difficult. Okay. So just take a look at that one. Just have to be, like I said, good with your fractions and your arithmetic, and you can simplify it out. We're just adding these components, so that wasn't too bad. Okay.